So now let us learn some more problems to find out the areas under curves. So on the screen you have a region colored in yellow and another region colored in green. So these are the two regions, and we have to find out the areas of the two regions. Now, the area which is shown in yellow color, it is under the line, while the region colored in green, it is under the curve or the circle. Now the equation of the line, it is given us y equal to x, and the equation of the circle, it is given to us as x squared plus y squared equal to 32. Now to find out the areas of the two regions, let us first start with the equation of the line. So the equation of the line is given as y equal to x. So here the powers of x and the power of y, they are equal to 1. Therefore, definitely this equation is an equation of a line. And this equation tells us that y is equal to x. It means that whenever you take any point on the line, on the screen you can see the origin and the point B, they are on the line. And any point on this line, the coordinates of those points, the x coordinate and the y coordinate, they will be always equal. Any point on the line, I have given to you two examples, the origin and point B, but you can take any point on the line. So you will always find that the x coordinate and the y coordinate, they are equal. Now, when we look at the equation of the circle, which is x squared plus y squared equal to 32, so x and y are actually the coordinates of any point on the circle. So this equation is telling us that if you take any point on the circle, and if we take the coordinates, the x coordinate and the y coordinate, we square them and we add them together, then always we'll be getting 32. And x and y, they cannot be equal all the time. For example, the point A on the screen, it is a point on the circle, and it is shown that the x coordinate, it is 4 times of root over 2, and the y coordinate it is 0. So the x coordinate and the y coordinate, they are not equal. But as the equation of the circle says, if we square 4 times of root over 2 plus the square of 0, and their sums will be equal to 32. So any point on the circle, if we square those coordinates, then add them together, always you will get 32. And x and y are not equal all the time. So now let us look at point B. this point B is a point which we have got because of the intersection of the line and the circle. So we have got point B. Now to find out the areas of the two regions, we need the coordinates of point B. Now how do we find out the coordinates of point B? Because they are not given in a question. Now, to find out the coordinates of point B, we will use the equation of the circle. The equation of the circle says that x squared plus y squared is equal to 32. And x and y are the coordinates of any point on the circle. If that point which you are taking, which is on the graph and not on the circle, then you cannot use this equation. But if that point is on the circle, then you can take the coordinates, you can square them, the x coordinate and the y coordinate, add the squares of the two coordinates, and then you'll be getting 32. So x squared plus y squared is equal to 32. And as you know, x and y are not always equal all the time. But since point B is also a point on the line, and because we know that B is a point on the line, therefore the coordinates, the x coordinate and the y coordinates, they are equal. Therefore, in the equation x squared plus y squared, you can say that x and y, they are equal. So, when x squared plus y squared is equal to 32, we can change to x squared plus x squared because y is equal to x. But remember, y is not always equal to x. But since we are talking about the coordinates of the point B, so only because of that, x is equal to y. Now, therefore, we can say x squared plus x squared is equal to 32. And because you have got x squared plus x squared equal to 32, on solving that equation, you will find that x is equal to 4. Now, when x is equal to 4, y also should be equal to 4 because we are talking about the coordinates of the point B, and point B is on the line, and as we know from the equation of the line that the x coordinate and the y coordinate, they are always equal. So when x is equal to 4, therefore y should be equal to 4, and therefore the coordinates of the point M should be 4, 0. Now, let us find out the coordinates of the point A. Though on the screen you have seen that the coordinates are already given, but remember, these coordinates are not given in the question. You have to find out. So, to find out the coordinates of point A, we will again use the equation of the circle because A is a point on the circle. Now, from the equation of the circle, you can replace y to be 0 because A is a point on the x-axis. So any point on the x-axis will have the y-coordinates equal to 0. Therefore, from the equation of the circle, we can say that x squared plus 0 is equal to 32. Because x can be any number, and only y we are sure that it is equal to 0. So since x is not sure, we cannot put x is equal to 0. Now on putting y equal to 0, So you'll be getting x equal to 4 times root over 2, and therefore the coordinates of point A should be 4 times root over 2, comma 0. So we have got three numbers on the x-axis, and that those three numbers are 0, 4, and 4 times root over 2. So using these three numbers, we can now use the definite integral to find out the areas of the region given in yellow color and the area of the region given in green color. So to find out the area of the region in yellow color, which is given in yellow color, we just need to integrate from 0 to 4 of y times dx, and to find out the area of the region given in green color, we just need to integrate from 4 to 4 times of root over 2 of y times dx. So whenever you are integrating to find out the area of the region shown in yellow color, y is always equal to x. And whenever you are integrating to find out the area of the region shown in green color, y, always remember, you can get from the equation of the circle, because the region which is shown in green color, it is under the circle. So whenever you talk about y, means you can get it from the equation of the circle. So since now we have got the limits, we know also the values of y. So therefore, using definite integrals, we can straight away find out the areas of the region which is shown in yellow color, and also the area of the region which is shown in green color. So that is what we have done. Now it is up to you to do it on your own and show that the area of the region under the line and under the circle, it is simply by adding the two areas. So area of the region which is shown in yellow color and added to the area of the region shown in a green color. So adding the two numbers, you'll be getting the area of both the regions. So the calculation are here, which I'm going to show you now, and the integrals will look somewhat like these. So the first integral, the first definite integral, will be of this form. So the area of the region in which is shown to you in yellow color can be found out simply by using the definite integral as integral from 0 to 4 y times dx. So y in this case, it is equal to x, because this region which is shown in yellow color, it is under the line. So because the equation of the line is y equal to x, therefore we simply replace y by x and carry out the integration. So the definite integral will now be equal to 8. So after getting this, let us find out the other one. And the area of the region shown to you in green color can be found out simply by using the definite integral as integral from 4 to 4 times of root over 2 of y times dx. And y in this case, you can get it from the equation of the circle, because the region which you are talking about, it is under the curve or under the circle. So on finding out the value of y from the equation of the circle, we are getting that y is equal to the square root of 32 minus x squared. So this is in fact a standard integral, and we can simply use the formula, and on using the formula you'll find out the area of the region in green color is actually 4 times pi minus 8. So on adding the two values, the area of the region which is shown to you in yellow color plus the area of the region shown to you in green color, then their sum is the total area, which is equal to only 4 times pi. You can add there 4 times pi square units. So that is how we find out the areas of the region under curves, and especially when one curve intersects the other curve.